We're starting with a talk by Sam. She works for Starfish Space, and I know Starfish has a watch party, so Starfish Space, enjoy the talk by Sam.
Hi, my name is Otter Pup. Well, actually, this is me. Wait, let me zoom in a little bit. That's better. This is me. I'm a small satellite the size of a microwave. And right after I got to space, I started spinning like crazy. And spinning in space is really bad. It's almost impossible to stop. But today, I'm thrilled to share with you how my friends rescued me with the help of data. So space has a data problem. There's too many satellites to keep track of, and now because it's more affordable and easier than ever to launch and deploy satellites, there's so many of them on orbit that we have a debris problem. And our mission at Starfish Space is to provide satellite services. So for our clients, we provide life extension, which will help them continue to maintain orbit and collect more data and transmit that. That'll reduce the need of launching additional spacecraft. Disposal, so we reduce the number of spacecraft and also minimize the risk of collisions, and so much more in the future. And we want to do all of this autonomously. So here's a quick overview of our small, cute spacecraft. We use a mix of flight-proven commercially bought components and key Starfish technologies. And this small, cute otter pup will grow up in the future to become a full otter to provide all of our services. Here's the otter pup again, and as you can see, it's relatively small, and we wanted it to be small because then it's affordable for everyone, and we can also develop it very quickly. And it was released to space with a SpaceX rocket and an orbiter payload carrier, or a satellite carrier. And this Otter Pup spacecraft is only as massive as about 3 adult river otters or 1 very large sea otter. So why did Otter Pup start spinning after getting to space? Well, orbiters showed that it had experienced a software anomaly that spun it up to almost a rotation per second. That's really bad. And then when we got data down from the Otter Pup, it only confirmed those results. The reaction wheels are typically used to stabilize spacecraft, and they were maxed out. We also didn't have attitude lock, so we didn't know where we were in orbit and where we were pointing in space. And we also experienced periods of low power, so we had near zero illumination of the solar panels on the spacecraft at times. So how did we fix it? Well, we used something called torque rods. 3 of these naturally exist on our spacecraft and also exist on several other spacecraft. So we had a thought, hey, why not use these and create a special algorithm for them? And that's exactly what we did. So torque rods work by producing a resulting torque, think the right-hand rule, and if we can time this resulting torque in the opposite direction and correctly with the tumbling otter pup, we can reduce its rotation rates. Our success is not only a win for the company, but also for the entire space industry, because now if any other spacecraft start tumbling, we know how to stop them with the help of torque rods. So how did data help with all of this? Well, we can't see Otter Pup in space, so we really rely on data to see what's happening. We use stuff like spacecraft velocity rates. The health of the spacecraft was very functional, and the functionality was very key to know during this effort. And we also rely on knowledge of the state of the components because timing the torque rods was really key to detumbling. So here's a graph, a simplified graph of our data from our rotation rate reduction over time. So as you can see, we started off spinning very fast, but then the natural forces of the Earth slowed us down, and then when we deployed our algorithm, our rotation rate reduced to 0 very quickly. However, the actual data from this is a lot more sparse, and that's because as the Otter Pup was tumbling, it was very hard to actually make connections with the ground stations to downlink this data. Overall, I'm just so happy that Otter Pup isn't spinning any longer. So how else does data fit in with space? Well, space is a problem of data. As an industry, we use data for all of these things and so much more. So this brings us to the question of what are some of the data challenges? So we have one of the problems is limited bandwidth. So we can't always get down as much data as we would like. We also have problems with the rate or frequency and ground station availability, so we can't get the data as fast as we want either. And then we also have periods of invalid data. So things like bit flips or software bugs cause problems, and we want to rely on multiple sources of data if we can. And then there's always the problem of visualizing this data to make fast and efficient decisions. Also, it's very expensive to operate spacecraft. So then whenever we run tests on orbit, we test on the ground 1,000,000 times to make sure not only does it pass successfully on the ground, but also that all of this data is enough to really verify the success of this test on orbit. In all of this, we also have the problem of doing all of this autonomously. So because the spacecraft relies on sensors to collect data from its environment and process it on board, we have things like latency delays, and we also have data pipeline management issues at times. And although we expect these problems to continue in the future, that's what makes all of this so much fun. I think Ashley and Victoria after me will really agree with this, but that's the best part of my job. I really love having all of this challenge and all of these puzzles to put together. And I really think that good data management in space is really key to operating anything in space. So I still have a few minutes left, but I will end a little bit early and leave off on one last note, that data is really our eyes into the cosmos. And it's really what enables us to operate spacecraft and do seemingly impossible things like detumbling a spinning otter pup. Thank you.
Fantastic.